'Cause you're a sky full of stars. I'm gonna
Hello, Pates. Welcome to our first lesson in Chapter 2. This chapter is entitled Reasoning and Proofs. Our first lesson is going to be on inductive reasoning and conjectures. And like always, before we get started, let's take a look at our content and language objectives.
Cause you're a sky full of stars.
Now that we have our content and language objectives set, it's now time to talk about two different kinds of reasoning. The first kind of reasoning is a reasoning we call inductive reasoning. The second we call deductive reasoning. Now, we are only going to be talking about inductive reasoning today. Inductive reasoning is when we take a lot of specific examples and we collect them over and over and over again. And then when we look at the data, when we look at all the information that's there, we begin to see a pattern emerge. And when we have that pattern, we then can make an educated guess about what is going to come next. And so inductive reasoning is when we do reasoning based on patterns. And that reasoning based on patterns allows us to make some conclusions, some decisions. Now, when we make our conclusions, we have a specific word for that. We call it a conjecture. A conjecture, again, is the conclusion based on the observations we see. So once again, we gather lots of data from very specific examples, and we look for patterns to help us explain what might happen next. When we have those patterns, we make conclusions about our observations and predict what is going to happen next. Now let's take a look at a few examples of inductive reasoning. Here is our first example of inductive reasoning. The directions say to write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item in that sequence. So our first problem says movie times are 8:30 a.m., 9:45 a.m., 11 a.m., and 12:15 p.m. Our task is to come up with the pattern in between the movie show times and then to write a conjecture about when the next movie show time will be after 12:15 p.m. So when we're looking at this line of movie times, hopefully a pattern will emerge. Now what I would like you to do is, if you want to, hit pause for a second and try to find the pattern before we talk about it. This will help to see if you really can find that pattern or if you're just relying on me for assistance. So, I've given you enough time to hit that pause button. Let's take a look at our answer now. You will see that the pattern between these four times is an hour and 15 minutes later. So 1 hour plus 15 minutes. Okay, from 8:30 to 9:45. If I go from 9:45 to 11 a.m., we see that that is again 1 hour and 15 minutes later. If we go from 11 a.m. to 12:15 p.m., again, that pattern looks like it holds true at still an hour and 15 minutes. So you see between the four times here, the pattern of adding 1 hour and 15 minutes to the previous showtime happens each time. So based off of this, I think we are ready to make our conjecture. Because each new showtime starts an hour and 15 minutes later, our conjecture, which I will write here, our conjecture is the next movie time will be, I almost feel like we need a drum roll here, but if we add an hour and 15 minutes to 12:15 p.m., we will come up with the time of 1:30 p.m. This is how we use inductive reasoning. We found the patterns, and based off of the patterns, we made our educated guess, our concluding statement that the next movie will be at 1:30 p.m. All right, Patriots, here's our second example of inductive reasoning. Same directions as the previous example. We need to write a conjecture that describes the pattern in the sequence, and then use that conjecture to write what the next item in the sequence is going to be. Here's problem 2. Follow-up visits. The first one happened in December, the second in May, the third in October, and the fourth in March. Our job is to figure out when is the next follow-up visit going to be. Reminder, go ahead and hit pause for a second and try this on your own first. Okay, now that I've given you that amount of time, let's take a look at our pattern that we see. Well, initially it's not very obvious what that pattern could be because there aren't really any numbers. Okay, these are months. But if we look a little more closely, let's try something here. Let's start with December and let's just count how many months it is until May. So we'll start with December. January, February, March, April, May. Okay, that took us 5 months. So I'm going to write from December to May, 5 plus 5 months. Now let's go from May to October. June, July, August, September, October. Well, look at that. It happens to be 5 months again. So let's write that down. Maybe we're seeing a pattern emerge. Who knows? Let's go from October to March. Bet you could guess what it might be. But here we go. November, December, January, February, and March. Again, 5 months. I think we have our pattern. Plus 5 months. So if this pattern holds true, we're ready to make our conjecture about when the next follow-up visit is going to be. Let's start. Here we are at March. Let's figure out when that next month is. We got March, April, May, June, July, August. August seems to be the 5th month. And so our conjecture is going to be that the next follow-up visit will be in August. All right, let's take a look at a different kind of example of inductive reasoning. Sometimes all you're going to be provided with is a statement. No examples, no nothing. And it will be your job to actually provide the examples in which you are going to find the pattern that emerges. Let's take a look at this example right here. It says, make a conjecture about the value relationships. List or draw some examples that support your conjecture. So in this question, we are asked about what we think the value of the sum of two odd integers is going to be. Now, odd integers, remember those are the integers of 1, 3, 5, 7, 9, 11, the ones that you cannot divide 2 evenly by. So in order to come up with our conjecture, the first thing you'll have to do is provide some examples in order to make our conjecture. What I would like you to do is come up with 4 examples of 2 odd numbers adding together, and so let's see what we come up with. Okay? Go ahead and hit that pause button and create your 4 number sentences. All right, now let's take a look at some examples of integer work. My first example here is I'm just going to take 1, add 3 to it. 1 and 3 are odd integers, and the value of this is going to be 4. I'm now going to take 1 and I'm going to add 5 to it. And the answer to that is 6. So far, I've got 4 and 6. Let's get a couple more examples though. I'm going to take the numbers 3 and 5, add them together, and I get 8. Well, it seems so far I've used pretty small numbers right now. But what about if I picked a couple bigger numbers? Let's use 11 and 15. 11 and 15, let's add 11 and 15 together. And when I do that, I get a value of 26. Now hopefully you started to see a pattern emerge. That when I add 2 odd numbers together, the result happens to be all numbers that are divisible by 2. In other words, the result are even numbers. And I think if we were to try it again with even bigger odd numbers, I believe we're going to see that same pattern emerge. And so let's write our conjecture now. Our conjecture is that the sum of 2 odd numbers is an even number. Again, these examples, you're going to have to actually provide your own examples. All right, Patriots, it's time for that type of problem that everybody loves to do, the real world based problems. I like this particular problem because it actually mirrors what happens in the world of business. Business people have to make inductive reasoning decisions all the time. They have to look in data for patterns in order to be able to make decisions about what to do with their business. Okay? So even some people, if their business is big enough, they will hire individuals called statisticians to gather data, to look for patterns, and to make some sort of conclusion. Some people get paid really good money to do this. But let's take a look at how we can do this in a real world setting. The problem says the table shows the total sales for the first 3 months a store is open. The owner wants to predict the sales for the 4th month. And here's the table as you see. In month number 1, they've only made $500 in sales. In month number 2, they went up quite a bit. Instead, they had a month of $1,500 in sales. In the 3rd month, they jumped up quite a bit now, and now you have a sale of $4,500. So what can this store owner predict and expect to happen in month number 4? Well, when we take a look at the pattern, and again, remember, pause if you don't want to hear the answer. Okay, here we go. If we want to figure out this pattern, let's first take a look and go between months 1 and 2. 500 to 1,500. That seems to me to be a jump of $1,000. But now let's take a look at from 2 to 3. That jump is $3,000. That doesn't seem to be the same pattern. So it's probably not adding. But what about multiplication? Let's take a look at from 500 to 1500. What do I multiply 500 by to get 1500? Hopefully you said 3. So if I multiply from 500 to 300, that would explain the 500 increase to 1500 increase. But what about month 2? From 1500 to 4500. Let's apply that times 3 to 1500. And when we multiply 3 times 1500, we get $4,500. There's that pattern that we're looking for. That pattern. So our store owner, we're now ready to make our conjecture. Our store owner's prediction for the 4th month. Our conjecture for the sales in the 4th month is, and now here's where we really have to think about our math. We're going to take 4,500 and multiply that times 3. I'll give you a second to do it on your phone calculator. Hopefully you're not watching this video on that too, on the phone. Make it happen. But if I multiply 4,500 times 3, I will come up with an answer of $13,500. That is going to be the conjecture for the 4th month of sales that we have, that the store owner will receive. All right, Pates, we have one more thing to talk about with inductive reasoning, and that is the idea of counterexample. Counterexample. Counterexample is simply the false, I want to capitalize it here, the false example. You see, we've been providing a lot of examples to show that something is true. We'd have examples, we'd find the pattern in order to predict what is going to happen next. But not all of our conjectures are going to be true. In fact, many of our conjectures seem true because of the examples we have. But what if I found an example that made the statement false? That is what we call the counterexample. So in order to prove that a conjecture is true, to show it's true, we actually have to have every single example be true. There can be no false examples. So we also want to look and to see if it's true. A way to prove that something is not true is to find a false example. Let's practice it. Here in this example, number 5, it says if JK equals KL, remember these are segment notations, meaning the length of segment JK is equal to the length of segment KL, then K is the midpoint of line segment JL. Now let's be perfectly clear when we write this statement. Whenever we see a statement like this, we are really saying that if this is true, JK equals KL, then every single time K has to be the midpoint of segment JL. Here's an example of what they're referring to. You see here how K is exactly in the middle. We mark it as the midpoint by using the congruent marks. But is this picture going to be true every single time? Could I find an example that has JK equaling KL, but not make K the midpoint? And believe it or not, there is such an example. Let's see. What if I drew a triangle? Now, when we look at this triangle, it looks like these two sides here could be the same length. I'm going to mark them the same length. And I am actually going to write here J, K, and L. In this picture, we see that JK, segment JK, is congruent to segment KL. But you'll notice that K is not the midpoint. This is an example of a counterexample. We have just shown that this statement is a false statement. It is not true 100% of the time. That's the idea of counterexample, the false example. Okay, Pates, it's now time for our 1-minute takeaway, which will begin right now. All right, Patriots, it's been a great lesson today, but now here's what you need to do. I want you to think about your 1-minute takeaway you just did. Maybe you wrote some questions down. Maybe you wrote an idea you had. Maybe you wrote a thought that inspired you, or maybe it was something I said. Maybe you were a little confused as I was walking through these particular examples. So, promise me, tomorrow when you come into class, the first thing I want you to do is come with questions. We're going to take the first 10 minutes of class tomorrow, and we're just going to answer questions that you had from this video in order to clear up any misunderstandings. Make sure you come with questions if you have them. Number 2, tomorrow we're going to be trying some new problems, some different problems with inductive reasoning and finding counterexamples. Make sure you're ready to try those. Okay? Be willing to participate. Which leads me to my third piece. Tomorrow in class, be ready to share your answers, but not just tell me what the pattern is or tell me what your conjecture is, but be able to combine the two and be able to explain your thinking and reasoning. It is the explanation that will make you that much better of a math student. I hope you enjoyed today's lesson. I look forward to seeing you tomorrow in class and in the halls. Take care, Pates.